Hello and welcome to another episode of Remote Pair Programming. Today we will continue on a problem called Good Friends. We worked on this before. We worked on it with TDD as if you meant it. And Wassel will tell more about it. So, could you please tell a few words about yourself and then about the problem?
Hello, good morning, Adi. So my name is Wassel, and I'm a consultant and developer at Octo Technology in Paris, France. Yeah, so basically the problem called good friends is because of the famous French proverb, good accounts make good friends. And basically the problem we're trying to solve is like four friends that are doing, touring. They want to reduce their payments. Like for instance, here um, you get Alice that paid an Irish coffee for herself, Bob and Claire, but not David this time. And the bill amount was 15. Then David paid a pint of Guinness for Alice and Claire, but not for the other two, and the bill was 8. And Bob has paid the lunch for everyone. When reducing these payments, what we want at the end is that we want the feature we're looking for is we want to balance debts, and then here we have the minimum amount of transactions that will balance the debts. Here, for instance, Alice owes €2 to Bob. Bob has no debts, and Claire owes €17 to Bob, and David. That means in two transactions, all of the debts are balanced.
Mm-hmm.
So this was a challenge that was made by a friend of mine who is Abel Andre. Here is his Twitter. And we have worked with you last time using TDD as if you meant it to tackle this problem. So here what we have done last time. So basically, here is some of our notes about the guidelines. So we did as recommended for red green refactor, but first we just take small amount of time to think how we can think about some aspects. For instance, what are the outputs that how we can represent this problem. The other thing here is slicing the behavior and simplify. So basically, we have started by two friends and an uniform debt, like just trying to compute balance 50-50. The first test we have written is that when Bob paid €40 and we want to split 50-50, then Alice owes €2 to Bob. And then we have done the same problem with another amount in order to not faking the implementation anymore. And then we have introduced another new concept. So each time we have written a test, we try to on one new concept. So after doing a list of tests, we end up with these two functions. So these two functions we have just extracted them by removing the duplication in the production part in the test. So at the beginning, each test they were production section or production code. And for this section, we have the implementation that has emerged, and then we have extracted, and we end up with these two functions. All right, so that was a small recap about last time. So let's continue this.
Yeah. So, what do you do now? What should we Focus on.
All right. So so now what we want is like okay, so we know how to compute balance, or maybe we can start with assembly factor in order to um, to take a property of this code again, because it was 2 weeks since last time.
Yeah.
So maybe we can do some renaming and try to see how we can simplify things.
Mm-hmm.
So I would suggest to start basically with not adding any behavior, but just doing some factor in order to take control of what you have. What do you think?
Yeah, sounds good.
All right, so let's start by simple things like renaming. So here we have a function compute balance 50-50. So I think that the name is good when you have only 2 friends. Then it's just split 50-50. But when you have more, maybe we can think about more qualified name. So basically here what we're computing is a debt. Maybe right. So I think that the word balance here is not appropriate because we're not balancing anything. It's actually that
Yeah.
debt.
Yeah, we're
So I would
computing at that.
suggest,
Yeah, that's for sure.
yeah. So yeah, maybe I think it's just call it compute debt. But there is another notion here is that it's just like the debt is the same for everyone. Like it's not it's not when it has paid more. It's like when you pay um, the lunch, you split it for everyone. There's no coefficient like for um, it's you don't have like um, you owe me 10 euros and
Yeah.
you owe me 2 euros because you've taken two extra um, shots at the end. I don't know.
Mm-hmm.
And we need to this notion of it's something uniform. I don't know if it does make sense if we just call it uniform debt, equidebt. Uh,
Yeah. I
what do you think about equidebt?
I don't
Does it
know
make
what
sense?
equi means.
I mean, you're right. It's not even a word. Like, what about uniform?
For
Um, I mean, what we want to highlight here is that it's the same amount for everyone.
yes, so the same for everyone. That means
Yeah.
what? Maybe uniform works for now. I don't know.
Okay, so I just leave it as
Yeah.
uniform for now, and then we'll see. Get debtor list. So basically, this function we have started implementing it by just faking it. So basically, here are the tests. So here we focus about who are the debtors. So who are people that owes money. Okay, so we have here, for instance, Bob paid an amount debtor. So all the friends are Bob and Alice, and we expect that Alice will be the debtor. Okay. Here is the same thing. There is something that is bothering me here is actually we are expecting lists. That means that like the order is important, which is here.
Mm-hmm.
I mean, we expect Alice and John, but it can be also John and Alice.
Mm-hmm. Yeah, we need another test for that, I
So,
guess.
that's interesting. But because where is for you the more generic things? Because I was just thinking that actually Alice and John, because here we are expressing two requirements, only one.
Yeah.
First requirement is we want these two elements, and the second one is that we are expecting them in this order.
I don't see anything explicit about the order. Here, I guess what you could do, it's either use two tests or use
Okay.
mutation testing.
Use what?
Mutation testing.
Mutation testing. All right. So here I see this because just because it's a list, and in the list you take order into account. That's
Yep. What other options would you see?
Is like sets here. For instance, if you put like here, what you expect is like Alice and John in any order, and then you then you don't I mean there is no problem with, and don't
Okay.
you don't care about in which order they come.
Okay.
All right. So to do this, I will break the test because I will break the test because what we are returning here is actually a list.
Mm-hmm.
All right. But if I change the list to a set, then I will break the other two tests. So
yeah.
All right. So what I will do here is like, all right, is I can change only one test here, and then progressively include the other test on the new implementation.
Yep.
Okay. All right. So let's just break one thing at a time. Here, for instance. Let's just do it here. Okay. So it is broken, and what we can do here is like we just inline this here. So, then here. All right. So here I make this just pass.
Yeah, that should work.
One up. Yeah. Then if I say that, all right, if I take my friends and then wait, then I make okay. Convert them to a set. Then I remove the tail. Cool, that works. I can do the same thing here. Is I'm expecting that I don't care about the order anymore. So here, and here is and here, so is the same here. And draw. That works. And now I'll take the same implementation to see if it's there.
It works there, yeah.
It's actually worked. I'll do it for the last time. Here, all the friends. Here are John and Alice. I don't care about the order. So it doesn't work anymore. That's it. And then the expected is no, here is it. Action code is work. So it's not working because I didn't. Alright, it's working. See if it still works. Disconnect. Nice, cool. Then here we have rule of three applications. So we can extract this method and let's call it pictures, and here my IDE has detected two more duplications, so I press him to replace it everywhere. All right, so okay, but so it's working. Still, there is something I don't like about it. So we have extracted a method within the test class, which is so far all I need is just a pure function. So I will get rid of the self here, and I will call there. Okay. All right. It's working. Cool. All right. And then I can just inline the production section because I have extracted the function. Okay. Okay, and by doing this, I mean,
inline that
doesn't have any sense, and we can just remove it. Yeah, makes sense. Okay. And I think and now the get the process is not used anymore. Yeah, and see that actually it simplifies a lot here because
Mm-hmm.
um, here it was like clearly a fake who was taking the friends or sorting them by putting the pair first, and then we just the list into lists and take just taking a sublist starting from the second element. Uh, I think this implementing makes more sense because actually vectors is the whole set of friends
Mm-hmm.
minus
Without the
the
pair.
pair.
Yeah.
Okay, without the pair. So we can now remove this implementation, even them here, and yes. So working, cool. Right, so let's just do a commit and
Yeah. It's time for
think
my
about
commit.
um, about the next steps. So here, refactor. All right. Choose with oh, all right. So it's now we can identify the debtors.
Mm-hmm.
We can we know who where is the amount. So to complete this behavior here, I think that the next notion we need to introduce is like who's owing to who.
Mm-hmm.
Um, so if we take this when Bob paid 50, then Alice owes Bob 20.
So that's split by consumption.
Sorry?
That is split by consumption, right?
Yeah, yeah. No. Let's. I think we can stick with the split 50, like 50-50, and
Okay.
I mean, just let's see what we need to complete this behavior.
Mm-hmm.
Like here, if we have Bob that pay 40, we can know that Alice owes 20. I
Yeah.
mean, what we need here is like when there is a sequence of payments and see at the end who owes to who.
Mm-hmm.
I mean, I was thinking about something like Bob paid um, right. Okay,
Yeah.
and Bob paid 100. Okay. Here is the output. There is like there is the two. Now to begin it anyway. And then the output should be like those 150. What do you think about this?
Yeah, that's good. because it's a sequence.
Okay. Yeah. This is a sequence.
But there's no split, like Bob paid only for Alice because it's 150. Yeah. So you know, because in the first case we said Bob paid 40 and Alice owes Bob 20 because it's a 50-50 split. So now we're changing a bit the rules, and it can be confusing from the point of view of documentation.
Yeah, I see. You're right. Okay, so
if it's like that, it should be 75.
All right. Anyway, okay, that can be. Yeah, you're right. Let's just stick with the same thing. Yeah, it should be 75.
It means the same thing. It's written in different way.
Yeah. Okay. Okay. What do you think about this?
Yeah, that looks good.
Okay. Right. So let's write a test. I will choose easier ones.
Bob paid 20 for Bob and Alice. So then it's 10 and 15, right? It's 25.
25, right? There you go. Okay. Good. Good. Here. Probably 25. Yeah, it's good. And here, 56 is description. And here is
Mm-hmm.
Here is not sure. So what's the direction? Right. But here is okay. Let's start here. But actually, don't need the string.
Mm-hmm.
There is like orange section. Okay, so right. how can we write this? So we want Bob. So basically, this test, the idea here is how to represent transactions. So actually, this is what we're trying to solve about this test.
Yeah. Two transactions, and then we need to
and as you said, a sequence of transactions. Okay, so so basic try to
how can we map that? So in the arrange, but I think we need to write the transactions in a way to formalize them in a way. So the transaction one was like a payment.
Payments. It's the word that we have used so far. So we have payments. And
I have a payment of 20 and another payment of 30. And there are a sequence.
So 20 and then we have 13. These are payments.
And now with these payments in production, we need to receive the payments and compute.
And actually here we have the payer who's still Bob.
Yeah.
And the friends.
Yes.
Are Bob and
Dallas.
Okay. So here, okay. To make this fast, we can. It's actually
the thing that we're just expecting 25. It's shouldn't we expect a bit more, like the amount that but also connected with the person.
Yeah.
So
okay.
I would say something like expect 25. So I don't know, it depends on how much design we want to make, but to make this correct, I guess you'd need to have like a structure to say this is the amount and this is the person who should receive the amount.
Okay, so like
yeah, something like 25 and Alice. And Bob, sorry.
Oh, like Alice. 25.
Or yeah, it depends how you look at it, of course. If it's a credit or a debt, or so it's either way, I guess.
But if you see this, that means that you need Bob 0.
Yeah, that would make it better.
Okay, I think I think this is what we are looking for. Okay. All right. So let's try to do this. I know, but Bob is not 25. Actually, it's still it's not 0, but it's still 25. Because
depends on. That's why I'm saying depends on what we expect there. If we'd expect how the amount of money one friend owes to the other, then for Bob is 0.
Yeah.
So you can think about a bit of a more complex scenario in the near future, like Bob paid for Alice 30, and then Bob paid 20 for Alice, but then Alice paid 15 for Bob. So then after this type of scenario, also Bob will owe something, but then we'll even out the two debts, and only one will make a transaction to even out the debt.
Yeah, I see. But here, it actually, yeah, I agree. But here, I think that it makes more sense if Bob owes 0 because he was the pair and he will not owe money to.
Exactly. Yeah,
so
that's what I'm saying. Yeah,
this is what we're looking for. But let's just do it incrementally. And then let's just say that instead of assert equals, we can just think about assert means, I don't know if there is something. So in, yeah.
Okay.
And then all, we just all we need is that in the
that's better. Yeah.
The debts we have Alice 25.
So you assert that in the expected there will be the actual, so that the production would return the list of debts or the people who owe debts.
Yeah. Yeah.
Okay, looks good.
It's actually debt details, or I don't know. Okay.
So
let's rename. Yeah.
Oh, okay. Rename it. I just wanted to suggest to make it run to see that it's red, and then try to make it green.
Right. Yes. So it's still red, and here it's because the production is not returable. So then I will just return an empty set, and here. Okay. So we didn't found Alice 25 in the empty instead I have returned. Okay. So here is what we're expecting. It actually is like this. Yeah. Details. Does it make sense?
Yeah, until now it does. Yeah.
Okay. All right. So, let's see. If we return here the a list of, so that works. So where Alice come from? Where does Alice come from? So it's actually so we can replace this by let's extract the variable here.
Yeah, it was already 3 times, so
yeah, but it's in the expectations as well.
That's good.
So here, sorry.
Yeah, that's good.
Vector, and this is the depth. All right, and if we try to use the functions we already have, which are the vectors, and here we have the friends and the player. Yeah. Good. It's not working because
Yeah, I would expect it that not to work.
you're right.
Let's see how it looks and
Yeah,
if we can use it or not. Can you
yeah.
go to debtors, please, to see how the function looks, what it does?
France, and then I remove the pair.
Okay, so that should work. Oh, it's a set, right? Just that.
Uh, yes.
So here,
yeah.
I think here the problem is that it's a set and you just need to take the only element from the set. So at line 127, you just need to
Yes.
filter it.
So actually, it fails here.
Yeah, but it's a set, and there you expect just a value.
Oh, the debtors. Oh, you're right. You're
Yeah.
right. So I don't know if I can access to the first element. No, it does not support indexing.
No, can't you just do something like...
Sorry?
Can't you just say something like get first, or isn't there like a function to do that?
Let me just check. Okay, I think it's just...
Oh, yeah. Yeah, now I remember.
Oh, yeah. Okay.
Good.
So, with the debtor, if you just take the first one, it's, yeah. Okay, so that worked. And then the debt, we have already the compute uniform debt, which take the expenses made, and here, that's interesting. So let's just say that it's 50, and the friends.
Mm-hmm. Yeah, but where did we get that 50? It's just hard coded.
Yeah, actually the sum of payments.
Mm-hmm. So then let's do a sum of payments.
Right. Okay. And it worked.
Great. Yeah, so I feel kind of uncomfortable to having functions inside functions without them being tested. So that thing with some payments, I would extract that to another line in order to make sure we have better visibility to spotting duplication.
Yeah, I agree. You're talking about the sum of payments.
Yeah, exactly what you're doing, yeah.
All right. So let's just call it does it make sense? Or amount?
Well, it's sum of payments. It's what does that mean? All payments? I don't know. All payments? How does that sound?
All payments?
Yes.
Yeah, it's only all payments you can maybe expect the sequence of payments. Um, it's even
It's not a
the
sequence. Well, it is a sequence. Yes, I guess, yeah. But it's the sum of
so it's an amount, or
yeah. Yeah, okay, leave it like that.
okay, all right, okay.
So let's
what
see.
would you suggest? Sorry.
We can refactor some more, or we can commit. Like there's Alice still there, duplicated, and you extracted Alice somewhere, or oh no, that just went away.
Yeah.
Okay, yeah. So if it's just something to refactor, if not, just let's run the tests again and then commit.
Okay, let's just commit. All right. Here, what we have done is sequence. Does this make sense?
Yeah.
Okay, so maybe let's go for the next test.
Yeah, I was thinking before that we have duplicated these things, so the names of these friends keep appearing. And I was thinking if having them all over the place would be a good idea, or refactoring them to just having them. That would be another idea. So why? Because I guess at one moment we can use them like personas, like our or characters from the game, you know.
I see.
And also maybe it will help with writing it faster. So if you have it already, you don't care if it's well spelled or not. It's just, you know, use the variable and that's all. And there's another reason why now Bob or Alice or whoever of these characters are just a name now. But I guess as we evolve the software, it will end up having other traits. So it would be interesting to try to evolve like Bob into a person who is always paying for everyone, you know, and have like a character like that. Or have the Alice, the person who is always late with payment. Or that would be an idea I had in mind. And also from the technical point of view, I start seeing that we'll have like a kind of an object keeping these things together. So it's like Bob, the name, who has paid this amount, or it has a history of payment, and who has needs to receive some money from Alice, some money from, I don't know, John, and so on. And it doesn't need to pay anything to the others. So I see this is where we're going because of the line 124 now, where already Alice has a debt. So that's a coupling, and that's a natural coupling, and I think that type of coupling should be part of an encapsulation.
Yes.
So I don't know when to do that, if you want to go on that direction or not, but that would be very interesting thing to do, in fact.
So I think that there are many concepts here.
Yeah.
I really agree about removing the application about the name, like creating structuring things about Alice, John, and Claire, and giving them a role, like personas, and putting them like a beginning of a test picture. And I think also it's both a real design concern here, and yes, it's also it helps for test maintenance here about the what these are concepts that are here start screaming to us, and we need to take care of them.
Yeah.
Okay, so let's start with Alice.
Yeah, I don't think in Python you can extract in between functions.
All right, let's just start. Okay, so I'm beginning with just call it Alice. Bob. Okay. Okay.
You could start a replace all, or
yeah,
but replace them one by one.
Okay. Here.
Oh yeah, that's why you need to replace them one by one.
It's done.
Yeah.
And now we can take care of Alice. I'll do same, and here I will go back. All right. Then we have John. Okay, go back. Not anything yet.
We have Claire.
And Claire. Okay, so cool. So, I can go even further, and like you said, these personas now qualify them. Basically, our Bob is like it's always the pair, so let's just call it Bob the pair.
Yeah.
What do you think?
Yeah, it would be nice.
Bob the plumber.
Yeah.
Remember the elections. All right, so here is Bob the player, and okay, what about Alice? So I think let's just do it here.
Yeah.
Stop here so far.
Yeah.
That's cool. Just run it here, and it's a refactor. Abstract friends. Cool.
Okay, so we've
All
been
right.
coding for like 50 something minutes. So let's
Okay.
finish this episode and then we'll go on with something else. Okay. So,
Okay.
So yeah, thank you for watching and see you next episode.